We are going to do an example that's going to look a little more technical than we saw yesterday. And so this example is if sine of A is 1/2 and cosine of A is positive, that's what the little greater than 0 means, and tangent B is 3/4 and sine of B is negative, then find the exact value of sine of A minus B. Now, because of my complete and utter failure at drawing straight lines on the video from yesterday, we have a nice little computer-drawn diagram of this. But I want you to find out why my triangles are drawn in these specific places. The triangle that has angle A in it is drawn in quadrant 1 because sine has a positive value of 1/2, and cosine also has a positive value. And quadrant 1 is the only place where sine and cosine are both positive. So I drew angle A in quadrant 1. And then since you know sine is opposite over hypotenuse, I put the 1 across from the A, the 2 on the hypotenuse, and of course we've seen this picture before, the square root of 3 on the adjacent, because of the Pythagorean theorem. Now the second triangle that has angle B in it is a little more difficult. It ended up being in quadrant 3 over here. The reason it's in quadrant 3 is because tangent was positive, which means tangent could be in quadrant 1 or quadrant 3 is positive, and since sine was negative. So sine is negative and tangent positive, that happens in quadrant 3. You'll notice that tangent is opposite over adjacent, and both of these are negatives, and when you divide a negative by a negative, that's why it works out to be a positive 3/4. So what we have to do is find the exact value of sine of A minus B, and we are going to use these two triangles that we just drew. So when you do a problem like this tomorrow, you're going to have to draw your triangles first and interpret where your angles go, because that will make a big impact on whether or not they're positive or negative. So I'm going to write then that the sine of A minus B can come from the formula. Even though I don't know angle B and I don't know angle A, I can use our formula chart for this. And our formula chart says that this is the sine of angle A times the cosine of angle B, and then it is minus the cosine of angle A times the sine of angle B. That's our formula for this. I want you to keep in mind that A minus B is a different angle, and I'm not even going to deal with that angle, and I probably wouldn't even be able to label those sides, but I can use angle A and B from this formula to calculate this. So let's see, the sine of A, well, that's given to me 1/2. The cosine of B is not given to me, but since we've drawn the triangle, we can find the cosine of B, and that is -4/5. And then minus the cosine of A was not given to me, but from angle A here I can see that the cosine of angle A is the square root of 3/2, and the sine of angle B was not given to me, but I could figure it out. It's -3/5. Alright, so now we get to do some fraction work. And if you don't know this, when you multiply fractions, you multiply straight across. So it's the top times the top and the bottom times the bottom. So this works out to be -4/10 plus 3 radical 3/10. We have the same denominator, so this answer is -4 plus 3 radical 3/10. And that is the sine of A minus B. So again, what you're going to need to do is you're going to draw the two triangles that have angle A and angle B in them as the reference angles. You're going to have to interpret what quadrants those are in from your other information. And if you don't know this little picture here, look at me in my straight lines. You know what? Yes, you're editing that. Don't even look. Edit. See, I can't even write the D. My thing is messing up. Edit. So I have a little box here. We're going to zoom down a little bit, and I'm going to draw a straight line. So here we go. Well, it's sort of slanted, but you get the deal. Straight up and then over. Okay, well, that was from a paperclip box, but at least it's better than what I drew before. In quadrant 1, all of the trig functions are positive in quadrant 1. In quadrant 2, sine is the only one that's positive. In quadrant 3, tangent is positive, and in quadrant 4, cosine is positive. And you might learn this. Is it a mnemonic when you have words that stand for all students take calculus? I think it's a mnemonic that you use whenever you have words for an acronym. I don't know what it is. Somebody tell me tomorrow. But all students take calculus is the mnemonic. Quadrant 1, all of the trig functions are positive. Quadrant 2, sine is the one that's positive. Quadrant 3, tangent is the one that's positive. And quadrant 4, cosine is the one that's positive. So that might help you. All right, the next example is to find the exact value of, and this is the reason that we have those formulas for sine of a minus b and cosine of a minus b and tangent of a minus b. Before these formulas, the only things we could do without a calculator are things like the cosine of 45 degrees. You can do that without a calculator because you can draw a triangle and do adjacent over hypotenuse. And it works out from a 45, 45, 90 that this is 1 over the square root of 2. You could find the sine of 30 degrees. You could find the tangent of 60 degrees. You could find the cotangent of like 90 degrees. But these were the only ones that you could find. Of course, you could go into quadrant 2 and do like 150 and 120 and 180, but they had to be multiples of this. With the formulas that we're learning, we can expand our knowledge without using a calculator and find how to get exact values. Because 15 degrees is not an angle that is a special right angle. We can't just label it. But what I can do is magical. I can write 15 degrees as a combination of these other angles. So if you can figure out how to use your 30s and your 45s and your 60s and your 90s as a combination to come up with 15 degrees, then you can use your formula chart. So one example would be, this is the same thing as the sine of 45 minus 30, because 45 minus 30 is 15. These two angles are angles that I can find exact values for. So from your formula chart, this is equal to the sine of 45 degrees times the cosine of 30, and then minus the cosine of 45 degrees times the sine of 30. And you can get that this is 1 over the square root of 2 times the square root of 3 over 2 minus 1 over the square root of 2 times 1/2. And we can get that this is the square root of 3 over 2 radical 2 minus 1 over 2 radical 2, which is the square root of 3 minus 1 over 2 radical 2. And if you type this in your calculator, you will get a decimal that matches the sine of 15 degrees. Isn't that neat? All right, let's do B. The cosecant of 15 degrees. Now this is where we are going to use a formula chart to our advantage. I could work this out to be, the cosecant of 45 minus 30 and try and throw it in some formula, but since I happen to know that cosecant is the reciprocal of sine, and I've already done the work for the sine of 15 degrees, I just need to do 1 divided by that. 1 divided by all of this. And of course the reciprocal means we just flip it over and multiply, and that works out to be 2 radical 2 over the square root of 3 minus 1. So I didn't really have to plug into a formula. And then our last one is the cosine of 75 degrees. Our last example anyway. The cosine of 75 degrees could come from, maybe I could do like the cosine of 45 plus 30 and plug it into a formula. Maybe I could do that, but I'm not going to because that's not the best way to do this. I've actually already done the work for this, but I could plug it in cosine of 45 plus 30, do the cosine of A plus B formula, and do it like I did in A. But since I've already done the work in A, I'm going to see, can I write cosine of 75 in terms of sine? Are sine and cosine related at all from that formula chart? Let's see. They are co-functions of each other. The cosine of theta equals the sine of 90 minus theta. Remember that from what we used yesterday? So this means that the cosine of 75 degrees as a cofunction is equal to the sine of what? It's equal to the sine of 15 degrees, and I've already done that. So that means cosine of 75 will have to be square root of 3 minus 1 over 2 radical 2. That is very smart. I'll see you guys tomorrow.